Hello, everyone. Before start our presentation, let's look at the woman behind some of the most important biological breakthroughs of the 21st century. I'm talking about Franz Arnold. She was born in 19 Arnold. She was born in 1956 in Pittsburgh. She originally studied mechanical and aerospace engineering, but her passion for solving global problems led her to do his master in chemical engineering in 1985. She is currently a distinguished professor at Caltech, where she leads a world-class research group. The defining moment of her career came in 2018 when she was awarded the Nobel Prize in Chemistry. She became only the fifth woman to receive this trophy. She was recognized for her work on the directed evolution of enzymes. Essentially, she figured out how to guide nature and create biological tools that didn't exist before, proving that we can use evolution as a powerful engineering tool. Okay. Okay. Now, you may wonder, what is a Nobel Prize winner doing today? Instead of retiring, Franz Arnold is pushing the boundaries of science even further by integrating artificial intelligence into biology. In her lab at Caltech, she is using machine learning algorithm to predict how enzymes will behave. This allows her team to design new proteins much faster than ever before. Her current focus is on sustainability. She's dedicated to creating green chemistry solutions. This means finding ways to manufacture medicines, chemicals, and materials using biodegradable enzymes instead of toxic chemicals or fossil fuels. As a global leader, she is also a frequent keynote speaking, inspiring the next generations of scientists to use technology for the benefit of our planet.
Her main biotechnological fields are the Y biotechnology, the industrial one, because she revolutionized this field by using the directed evolution to engineer high efficient enzymes, using these biocatalysts to replace harsh chemicals in the manufacturing of the industrial processes. The other color she is mainly involved is the green biotechnology, related with the environment, because her work focuses on the sustainability through the development of renewable energy and sustainable fuels, converting the plant sugars into advanced biofuels, providing a carbon neutral alternative to the petroleum. She has successfully moved laboratory breakthroughs into the global market through several foundations. In 2005, she founded Gibo to develop renewable fuels, especially focusing on the commercialization of isobutanol. Later, in 2013, she co-founded Provivi, a company that utilizes directed evolution to develop sustainable and pheromone-based pest control, providing a non-toxic alternative to the conventional agricultural pesticides. Her expertise in managing the intersection of science and industry is further evidenced by her leadership roles. She currently serves on the board of directors of Illumina Inc. and Alphabet Inc. Through these organizations, she continues to ensure that the principles of sustainable biotechnology guide the future of the global innovation. In order to understand Dr. Arnold's impact, we must first define her most significant contribution, the directed evolution. This is a method that mimics the natural process of evolution in a laboratory setting to create proteins with improved or entirely new functions. It involves subjecting a gene to cycles of random mutagenesis and is followed by the selection of the variants with the most desirable traits. Because of this breakthrough, Dr. Arnold is exceptionally relevant today. Her work enables the creation of cleaner and more sustainable technologies that fundamentally reduce industrial pollution. By utilizing these evolving enzymes as biocatalysts, industries can perform chemical production using significantly less water and energy, supporting environmentally friendly processes that were previously impossible through traditional chemistry. Her technical contributions have transformed how we manufacture essential goods. A landmark success of directed evolution is the production of many valuable enzymes, including the one used for manufacture Januvia, a prominent drug for type 2 diabetes. This, biologic, this biological approach allows for a more efficient synthesis that completely eliminates the need for toxic heavy metal catalysts, which were once a dangerous necessity in the drug production. Otherwise, this technology has produced catalysts that allows industrial chemicals and fuels to be synthesized from renewable sources instead of petroleum. For instance, directed evolution allowed for the creation of an enzyme that makes it possible to convert plant sugars into isobutanol, a high energy precursor to sustainable jet fuel, providing a neutral and sustainable alternative for the energy sectors.
So, in addition to its scientific importance, this work also raised several ethical debates and challenges. Because first, there was a discussion about patents and ownerships of genetically modified enzymes. This raises important questions such as about whether biological discoveries should be private owned or shared to be benefit for society. Second, the scientists and the public expresses concerns about the long-term environmental impact when modify biological systems. We must consider how these changes might affect ecosystems over time, especially if modified organisms interact with natural environments. Another ethical concern is the idea of modifying life itself, sometimes described as playing God. This reflects the deeper philosophical questions about the limits of human intervention and the natural processes and our responsibility as scientists. And finally, scientific integrity played an important role because in 2020, a related study was retracted, which demonstrates the importance of the transparency, honesty, and self correction in science. So overall, these debates highlight that biotechnology is not about scientific field. It's also an ethical and the area that requires careful consideration of its impact on on the society and the environment. In conclusion, her work clearly shows the importance of biotechnology in today's world and its growing impact on our future. Biotechnology helps create sustainable solutions in essential areas such as energy, medicine, and industry. By using biological systems, scientists can develop more efficient processes that reduce pollution and minimize the environmental harm, making production cleaner and more responsible. In addition, biotechnology plays a key role in addressing global challenges as climate change and the depletion of natural resources. It offers innovative ways to produce energy, improve healthcare, and support more sustainable and balanced relationship between humanity and the environment. Overall, her work demonstrates how science is not only a tool for discovery, but also it can be a powerful force that can help build a more sustainable, efficient, and hopeful future for humanity. So now for the open questions, I would like to address two important questions. First, what did Francis Arnold contribute to biotechnology? And then, well, Francis Arnold contributed by developing a method called directed evolution. This technique allows scientists to evolve enzymes in the laboratories to make them more efficient and useful. Her work was helped to create better medicines, cleaner industrial processes, and more sustainable technologies. Because of this, she was awarded with the Nobel Prize of Chemistry in 2018. And by second, why is sustainable technology important for the world? So sustainable technology is important because it helps to reduce pollution, protect natural resources, and address climate change. This allows us to meet human needs while preserving the environment for future generations. Overall, Francis Arnold's work shows how biotechnology can help to create a more sustainable and responsible future.